On this video, we are finding the maximum and minimum values of the function k of x on the closed interval from 0 to 8. K of x is defined as x plus 5 over x. We're going to have to deal with finding critical values and then critical points, and then find the endpoints and compare and contrast. Let's go ahead and do that. I want to start by rewriting my function. This 5 divided by x is going to be better off if I think of it as 5 times x to the minus 1. So k of x can be written as x plus 5 times x to the negative 1. And that's going to be easier to utilize when I'm finding some critical values. How am I going to find a critical value? Well, I'm going to take a derivative of my function. In this case, that's going to be 1 minus 5 times x to the negative 2. I'm going to set that equal to 0. 0 equals 1 minus 5 times x to the negative 2. Then let's solve for x. I'm going to add 5x to the negative 2 to both sides. When I do that, I get 5x to the negative 2 equals 1. Or we could also write that as 5 over x squared equals 1. This is a little bit easier to see because I can multiply both sides by x squared. We get 5 is equal to 1 times x squared is just x squared. This means that x is either the positive square root of 5 or x is equal to the negative square root of 5. Since my interval is between 1 and 8, what I can do is I can take the negative square root of 5 and just run a line through it. And that means I only have one critical value in this interval, and that's what happens when you have an x value of square root of 5. So I have a critical value when x is equal to square root of 5. I also have two endpoints, one of which is at 1, the other of which is at 8. By the way, I didn't say this earlier, I probably should have, but I set the derivative equal to 0. Is there a way that this derivative could have been undefined? Well, yes, there is. When you're dividing by 0, this thing could have been undefined. So this could have been undefined when x is 0. So that's another critical value that we would have needed to consider, but I knew that wasn't going to work because 0 is not in my interval between 1 and 8. So x equals 0 can also be scratched if I'd like. So we kind of had 3 critical values, 2 of which we scratched, 1 of which we kept, and then we're keeping the endpoints as well. Let's go ahead and find the critical point. Critical point is going to have x value of square root of 5. Its y value is going to be what you get when you plug in square root of 5 into this. That's might be hard to do. Square root of 5 plus 5 divided by square root of 5. I'm going to give just an approximate right now. Square root of 5 plus 5 over root 5. Approximately 4.47 is what I'm getting as the output. If I wanted to be more precise, I'd go square root of 5 and say that the output is square root of 5 plus 5 over square root of 5. I don't like this exact value so much because it's going to be hard to compare with minimums and maximums. It's a little bit easier to compare this rounded number when we're looking for minimums and maximums. Now, that's just the critical point. We have 2 endpoints that we have to deal with as well. One of those endpoints has an x value of 1. And then its output is going to be 1 plus 5 over 1. That's easy enough to calculate. That's 6. The other endpoint is going to have an x value of 8. And the y value is going to be 8 plus 5 over 8. 5/8 as a fraction is 0.625. So you end up with 8.625. You can see which one of these endpoints is the maximum by looking at the highest output value, 8.625. And you can see that the critical point is actually the minimum because it has the minimum output of 4.47. So there we are. We found the maximum and minimum of this function on the interval from 1 to 8. And that's what we're going to do in this section.